Mycobacterium tuberculosis is a death-causing organism that is already resistant to 2 first-line drugs, and depending on which strain you have, is already resistant to some second-line drugs. There are currently 2 different strains of it recognized, but they are evolved from the same strain. There was the regular strain of TB, which wasn't immune to any antibiotics, but now there is the MDR-TB, or multi-drug resistant tuberculosis, which is resistant to isoniazid and rifampicin, which are 2 first-line drugs, and there is the XDR-TB, or extensively drug-resistant tuberculosis, which is also resistant to the same as MDR-TB, but it is also resistant to any second-line drugs and a fluardoquine loon. This microorganism has evolved a long way from its original state in ancient Egypt, where it is believed that it first existed, although it maintained its deadly traits. It was first described by Benjamin Martin in 720 in his book A Theory of Consumption. He noted it as small living creatures being transmitted in the air. This was actually a very accurate way of putting it for the time, and it led the way for the next biologist who wanted to learn about it. The next biologist was Robert Koch, a well-known biologist and also a Nobel Prize winner, who discovered it in 1882, and doctors took his findings so seriously that they advanced his research by diagnosing it with antibiotics. Although natural selection has its ways and uses the rule survival of the fittest, there were a few of these bacteria diagnosed with the antibiotics that were able to survive, most likely because of a mutation that made them immune. They then reproduced, and the trait that made them resistant to the specific antibiotic was passed down to their offspring. They continued this until their whole population of bacteria was resistant to the antibiotic being applied, and the bacteria that weren't resistant died off, which was the original TB strain. The doctors applied a different antibiotic, and the natural selection had its way again. Again, the ones who survived this antibiotic reproduced, and eventually the bacteria became resistant to this antibiotic also. The cycle repeated itself and still is today. The bacteria are now resistant to many types of antibiotics, including 2 first-line drugs, isoniazid and rifampicin. Thus, we must firmly call this process evolution, because the Mycobacterium tuberculosis population has diversified from its previous strain to create 2 new strains which are resistant to almost all antibiotics. Mycobacterium tuberculosis causes tuberculosis, as in its name. Tuberculosis is when a Mycobacterium tuberculosis bacterium settles in your body and uses mitosis to reproduce to form tubercles in an aerobic area, such as the lungs or throat, and then parts of these tubercles diffuse into the bloodstream, which also contains oxygen, until they infect other parts of the body, such as the brain, heart, or intestine. The lungs and throat are a great place for the bacteria to invade and enjoy fresh oxygen you breathe in and still diffuse into your bloodstream. It causes terrible symptoms such as coughing, throat swelling, sweating, choking, vomiting, stomach cramps, and worst of all, death. Whether you die if you get this disease varies upon the time when you lived. Prior to the 1900s, everyone who got this disease ended up dying because they didn't take antibiotics to prevent it. Although between the 1900s and 2000, deaths of tuberculosis went down because there was discovery of antibiotics and they prevent those from dying. Although at this point in the 21st century, the choices of antibiotics that you can actually use on the bacteria that the bacteria isn't already resistant to is a very small number. The original strain of this bacteria has evolved into the MDR-TB strain and the XDR-TB strain, which have more resistance. Why? Because as more people use these antibiotics, the original strain evolved into more resistant strains. That is why tuberculosis is now a superbug. So far, MDR-TB is resistant to 2 first-line antibiotics, isoniazid and rifampicin, and XDR-TB is resistant to the same 2 antibiotics, plus 1 fluardoquine and at least 1 second-line antibiotic. They are resistant to these antibiotics because they went through mutations that have allowed them to become resistant to these antibiotics, and by natural selection they have survived and reproduced most successfully when exposed to them. Since these antibiotics no longer work on the new population of bacteria, they are no longer useful for the bacteria, and a new type of antibiotic must be used to kill the bacteria. Although the strains are resistant to these types, there are a few others available. MDR-TB has some more reliable third-line antibiotics, and some less reliable second-line antibiotics. However, when it comes to XDR-TB, it is very rare to get and very hard to get rid of. It is still possible to cure if you take different kinds of antibiotics for extremely long periods of time, but you have to remember it's already resistant to first, second, and third-line drugs, and there's really no other option. So I've been talking about these antibiotics and they help out, but let's go into depth about how they actually work now on the bacteria. Take a first-line drug, ethambutol, for example. First-line drugs are tablets, so first you eat the tablet and it should travel into your stomach and dissolve a little bit, although it does most of its dissolving once it hits your intestine. Once there, it gets sucked into the lining of the intestine and diffuses into the bloodstream. Then it travels to the infected area of the body. Once it meets the bad bacteria that it's being used for, it attacks it and kills it by invading the bacteria's cell membrane and destroying its inner contents. This saves our body the energy from attacking it ourselves if we were able to, like in earaches. Although, as I mentioned earlier, there are second and third line drugs also. Second line drugs are not very good for treating TB because they are less effective against the bacteria than the first line antibiotics. They are toxic, and they are injected straight into the bloodstream, which could lead to other diseases. Third line drugs are drugs that have not been fully tested yet. This group can be suggested, but they cannot be guaranteed until they are fully understood and have been tested for all possible side effects. They could one day become first line or second line drugs. Thus, first line drugs are the best possible choice for fighting this bacteria. Overall, Mycobacterium tuberculosis is a deadly organism that is costing thousands of lives yearly. Tuberculosis has been around for millenniums, as it's been found in ancient Egyptian mummies and in Greek and Roman cities. Many died from it before the use of antibiotics, and now many are dying from its resistance to them. The bacteria infect your body and ultimately cause death if not treated. As of now, we are running out of antibiotics to use against them. In the future, we may completely be out, and thus again, as before the 20th century, be without cure for Mycobacterium tuberculosis.